So 83%. 83% of organizations admit that their current cloud infrastructure is, well, it's fundamentally unprepared for autonomous AI agents.
Yeah, it's a terrifying statistic, honestly.
Right. I mean, think about that for a second. We are all rushing to deploy this AI that can, write its own code, analyze its own data, and yet the vast majority of enterprise systems out there are essentially just flying blind.
They really are.
So welcome to this deep dive. Today, we are taking a really hard look at the massive Google Cloud Platform Technology Nuggets update, the one from the first half of July 2026.
And it is a dense update.
Oh, totally, which is why our mission today is to just cut through all that marketing noise. We want to figure out exactly how you, the practitioners listening, are supposed to build, secure, and actually run these autonomous systems without, completely breaking your infrastructure.
Right, because it's a critical gap we have to bridge. I mean, we're way past the phase where AI was just some fun chatbot you played with on the side. These updates, they're entirely focused on production-grade agentic systems. So we're talking about really deep integrations into databases, automated code optimization, and the actual physical hardware required to keep everything from just crashing.
Yeah, and as we dig into all this, we are going to keep things incredibly grounded. So just a quick rule for today. For those of you who might be newer to the Google Cloud Platform, or maybe you specialize in one area and just haven't touched the others.
Which happens a lot, by the way.
All the time. So we will make sure to quickly frame up what these specific tools actually do in the real world. You are not going to need a dictionary to follow along today.
Good call.
Let's just start with the creation phase, because before you can secure an AI agent, you obviously have to build it first. And Google just made AlphaEvolve generally available.
Yeah, so AlphaEvolve, it is this really fascinating shift in how we approach software engineering altogether. It's basically a coding agent powered by Gemini.
And Gemini, just to clarify for everyone, that's Google's flagship suite of generative AI models, right?
Right, exactly.
Yeah.
But AlphaEvolve, it doesn't just, auto-complete your code like older tools. It uses what they call an agentic harness.
An agentic harness.
Yeah, to explore these massive search spaces to find the absolute most optimized algorithm for a specific task.
Okay, so when I first read the term agentic harness, I immediately thought of evolutionary biology. Mutation and natural selection.
Oh, that's a good way to look at it.
Because you start with this baseline seed program, right? Which is basically the DNA of the algorithm you want to improve. And then you define a deterministic scoring function, which acts like the environment testing that DNA for fitness. Like a master chef testing thousands of recipes at light speed.
That is a highly accurate analogy, actually, because that scoring function, it's very rigid. It tests the code for strict metrics like correctness and execution speed.
Right.
And once you have those two pieces, the seed and the scoring function, the agentic harness just takes over. It mutates the code, generates hundreds or even thousands of candidate programs, and then tests every single one of them against your scoring function.
But wait, if it's mutating and testing thousands of variations, isn't that just a massive waste of compute? I mean, I see a huge bottleneck there if it's just brute forcing random code changes.
Well, it's not brute force. And that's exactly where the Gemini model comes in.
Oh, okay.
It uses the scalar metrics from the scoring function to actually learn. So it submits the results back to the API, identifies which mutations improve the performance, and then mathematically directs the search space toward the optimal solution.
So it's not just guessing?
No, not at all. It does the grueling trial and error work systematically. And then once it finds the optimal algorithm, the fourth and final step is simply applying it to your production environment.
Wow. So it's literally guided evolution at light speed. I mean, that is a massive workflow change for developers.
Huge.
And speaking of speed, the generative models themselves got a pretty major upgrade in this release, too. The Gemini Enterprise Agent platform introduced Nano Banana 2 Lite.
Yeah, the naming conventions are always so colorful with these things.
They really are.
But the capability here is serious. I mean, it generates and edits images in 4 seconds.
4 seconds. That is incredibly fast. But usually, when you scale generation speed to that degree, you lose fidelity, right? How does it handle complex inputs without just falling apart into pixel mush?
Well, the architecture improvements focus specifically on world knowledge and text localization.
Okay.
So it understands spatial relationships a lot better. meaning it can place localized text naturally within an image without that typical, garbled AI artifacting you usually see.
That weird alien text.
Exactly. And alongside it, they also launched Gemini Omni Flash, which is priced at just 10 cents per second for conversational video generation and editing.
10 cents a second. See, generating video at scale has traditionally been so cost prohibitive for enterprise applications. That price point changes the math completely.
It really does.
But you know what I actually find more interesting than the speed or the cost? It's the default security posture.
Oh, definitely.
Because both of these models integrate CTPA content credentials and synthide watermarking by default. You don't have to opt in. And in an enterprise environment, having those invisible cryptographic watermarks built into every piece of generated media, that's non-negotiable for maintaining trust these days.
It's a structural requirement now, absolutely.
Yeah.
But, we also have to recognize that enterprise AI isn't just a Google-only ecosystem.
Right.
Practitioners are always bringing in third-party models, which is why the integration of Anthropic's Claude models is arguably one of the most important updates in this entire release.
Yeah, so GCP is now fully managing the Claude models through Model Garden. And for anyone unfamiliar with that term, Model Garden is essentially a unified library on Google Cloud where you can discover, test, and deploy various machine learning models.
Right.
So the fact that Google is managing Anthropic's models directly is a massive shift.
It solves such a major friction point because previously, if you wanted to use Claude, you had to manage external API calls yourself, which inherently creates security vulnerabilities.
Yeah.
But now, teams can invoke Claude using standard REST and JSON endpoints, but they completely inherit GCP's native security infrastructure.
Which is huge.
Yeah, it means your Claude deployments are protected by IAM and VPC's service controls right out of the box.
And just to quickly frame that up for you listening, IAM, or Identity and Access Management, that handles the who, like who has the authorization to trigger this model.
Exactly.
And then VPC service controls handle the where. They basically draw a virtual network perimeter around your resources so your proprietary data can't just leak out to the public internet.
Right. And because you have that native perimeter, you can actually control the data sovereignty. So Google introduced 3 specific routing endpoints for these third-party models.
Okay, break those down.
Sure. So if your priority is maximum uptime and failover, you use the global endpoint. But if you operate in a highly regulated industry, like, say, European banking, and your data absolutely cannot cross a border.
You use the regional endpoint?
Exactly. And then if you need resilience localized to a specific geography, you use the multi-region endpoint.
Okay, so you get the raw intelligence of Anthropic, but with the strict compliance and routing rules of Google Cloud. That makes total sense why Google was just named a leader in the IDC MarketScape for foundation model software.
Yeah, it's a powerful combo.
But, an AI agent, no matter how securely it is routed, it's functionally useless if it can't actually access your business data. Building the agent is really just the first step. How do we safely plug these brilliant models into our actual databases?
Well, that brings us directly to the data warehouse. So Google rolled out conversational analytics in BigQuery.
And BigQuery, again, just defining our terms, that's Google's fully managed serverless enterprise data warehouse, where companies store just massive petabyte-scale analytical data.
Spot on. And this new update, it allows practitioners to author specialized agents that query this data using natural language.
So wait, instead of a data analyst writing some complex multi-page SQL join to figure out, why sales dropped in the third quarter, they can just ask the agent in plain English.
Exactly that. It executes multi-step analysis and visual reporting natively.
Wow.
And the best part is it's not restricted to just native BigQuery tables. It queries Apache Iceberg formats and even cross-cloud sources like AWS Glue or SAP.
Really? Cross-cloud?
Yeah. Plus, it leverages built-in functions like AI key drivers to automatically find correlations or AI forecasts to predict trends.
That significantly lowers the barrier to entry for data analysis, but I do have a fundamental issue with this.
Well, what's that?
Well, if we are relying on natural language agents to retrieve critical financial or operational data, how do we actually know they are retrieving the right context? Because the standard way we evaluate AI right now is just a simple pass-fail test.
Right.
We ask it a question, and it either found the right data or it didn't. Did it pass or did it fail?
And that pass-fail benchmark is deeply flawed because it's entirely subjective, right? It doesn't actually tell you the structural limits of the AI's comprehension.
Exactly.
So to solve this, Google introduced Discovery Bench. It's a new framework designed to systematically evaluate how effectively AI agents actually retrieve data sets.
Okay, so how does it move past pass-fail?
By treating query difficulty as a mathematically measured quantity. Discovery Bench uses a concept from information theory called surprisal.
Surprisal.
Yeah, it measures query complexity in actual bits of information.
Okay, I need a concrete example of surprisal in action. How does adding bits change a query?
Sure. So suppose you ask an agent, what was our total revenue last year? That is a very low surprisal query. It's direct. Now, suppose we modulate the difficulty by adding steering terms. So we ask, what was our total revenue last year, excluding the discontinued hardware line, adjusted for European currency fluctuations, and cross-referenced against Q3 supply chain delays?
Okay, yeah, you've added a massive amount of complexity there.
Yes, you've increased the surprisal, so Discovery Bench systematically adds and removes these steering terms to find the exact threshold, the specific number of bits where the AI agent gets confused or fails to retrieve the correct context.
Oh, wow.
So you aren't just saying the model failed, you are mapping the exact cognitive limit of the agent.
That is incredibly precise. You can literally go to your engineering team and tell them, look, this agent operates perfectly up to 40 bits of surprisal, but it completely fails at 45.
Exactly.
That changes how we test AI entirely. But what if you don't want to pull data out into an external agent at all? Like, what if you want the intelligence to live directly inside your transactional database?
Well, for transactional workloads, you'd look at AlloyDB AI functions.
And AlloyDB is Google's fully managed PostgreSQL-compatible database service, right? The one built for really top-tier enterprise workloads.
You got it. And with this update, you can now run text generation, ranking, forecasting, and even sentiment analysis directly within the database itself.
Okay, running models inside the database sounds amazing for latency, sure. But if I have a table with, say, 10 million rows, and I run an AI sentiment analysis on every single row,
It gets expensive fast.
the compute costs and the network latency would absolutely crush the system. Row-by-row model calls are notoriously inefficient.
Which is exactly why the most critical feature in this AlloyDB update is smart batching.
Smart batching.
Yeah. Because without smart batching, executing a model call on 1 million rows means 1 million individual network round trips to the AI model. The overhead is just astronomical.
Right.
But smart batching intercepts those calls. It transmits the boilerplate model instructions only once, and then it automatically groups the row data into optimized payloads.
Okay, so it basically calculates the optimal batch size under the hood without the developer having to write all that complex throttling logic themselves.
Precisely. It drastically reduces both latency and compute costs just by minimizing the network hops.
That's a really elegant solution. But, okay, let's take a step back and look at the bigger picture here. Because we've got autonomous agents writing in test code. We have natural language models querying our deepest data warehouses. We have AI running directly inside our transactional databases.
That's a lot of access.
It is. And that brings us right back to that terrifying statistic from the beginning of the deep dive. If 83% of organizations don't have the infrastructure to support this, how are we supposed to run all of this without accidentally exposing our credentials or just blowing up our host environments?
Isolation. Isolation is really the only answer here. You have to operate under the assumption that LLM-generated code is inherently untrusted.
Okay.
So to address this, GCP rolled out Cloud Run Sandboxes in public preview.
And Cloud Run is the managed platform that lets you run containerized applications without having to provision or manage any of the underlying servers.
Exactly.
So I look at these sandboxes as like blast-proof rooms built directly inside your application architecture.
I like that.
Because if you have an AI agent that executes user-submitted scripts or an LLM code interpreter, you can't just run that code out in the open. The sandbox isolates that untrusted code. It limits the system calls, and it executes in milliseconds, but it has zero access to your host application data or your underlying cloud credentials.
Yep.
So if the AI, I don't know, hallucinates and writes a malicious infinite loop, it just detonates inside the blast-proof room, and the rest of your system is completely unaffected.
Right. That runtime isolation is critical for system stability. But securing the runtime, that's only one side of the coin.
What's the other?
You also have to secure the developers themselves, especially when they are utilizing third-party tools like Anthropic's Claude Code.
Oh, right. Because Claude Code is an incredible agentic tool for developers. But if you have an engineering team of 1,000 people, you cannot have 1,000 individual API keys just sitting locally on their workstations.
No, absolutely not.
That is an absolute nightmare for security and, honestly, for billing.
Yeah, it always leads to shadow IT and just totally uncontrolled spending. So the solution Google introduced for this is the self-hosted Claude Apps Gateway.
Okay, how does that work?
It centralizes the governance of these tools. So instead of using local API keys, the gateway routes all the authentication through an OIDC identity provider, like Google Workspace.
Ah, so the keys never actually touch the developer's local machine.
Never.
And I imagine the finance team loves this because the gateway also enforces server-side role-based access control and, crucially, token spend caps, right?
Exactly. You can actually govern exactly how much compute your developers are using on these agents. Brings all that shadow AI development completely out into the light.
That's brilliant. But, securing the developer workstations still leaves one major vulnerability, I think.
The clusters.
Kubernetes clusters themselves.
Right.
And Kubernetes, or GKE on Google Cloud, that's the orchestration engine that automates the deployment and scaling of your containerized applications. It is where the actual work happens.
And it is notoriously where developers love to sneak in unapproved tools.
Oh, totally. An engineer wants to test a new model, so they just spin up a rogue vector database or some unapproved VLLM stack in the cluster. I mean, they are just trying to move fast, I get it, but it leaves the site reliability engineers, the SREs, completely blind to what is actually running in their own environment.
Yeah, and to solve that specific visibility gap, Google open-sourced a new controller called K8s-ABOM, and it operates directly inside your cluster.
Okay, but how does it track what the developers are doing without forcing them to jump through bureaucratic hoops? Because if you slow developers down, they will just find a way around the tool. That's a universal law.
It is. But the brilliance of K8s-ABOM is that it requires absolutely zero pod modifications from the developers.
None.
None. It's a very lightweight controller that continuously monitors the resources via unprivileged runtime monitoring. So it just watches the actual execution states and generates machine learning bills of materials, or ML bombs, in real time.
So it acts like an automated invisible inventory scanner.
Essentially, yeah.
It just quietly logs every new piece of AI tech that spins up in the cluster and hands the SREs a complete map of their shadow AI without ever interrupting the engineering workflow. That is phenomenal.
It really is.
But okay, all of this monitoring, the sandboxing, the agentic code generation, all of this requires serious compute power. The physical hardware has to keep up.
Oh, for sure. And the infrastructure upgrades in this release definitely reflect that demand. For example, GKE autopilot clusters. They now feature managed DRANet for GPUs and TPUs.
Nice.
Which automates the highly complex network resource allocation you need for distributed AI training.
They also made the new C4N virtual machines generally available, right?
Sure. Yes, they did.
And these are powered by the 5th-gen Intel Xeon processors. But I think the standout feature is that they are built on the titanium offload architecture.
Yeah, the titanium architecture, it fundamentally changes how data moves through the cloud.
Let's break down how it actually does that, because traditionally the main CPU of a server, it has to handle the application logic, sure, but it also has to process all the incoming and outgoing network packets.
Right.
And when you are moving massive AI data sets, the CPU just gets bogged down managing all that traffic.
Exactly. So Titanium solves this by physically offloading that network and storage processing from the main CPU onto dedicated hardware cards, specifically data processing units.
Ah, okay.
And by removing that burden, it frees up the main compute cycles, which drastically reduces latency for all those data-heavy x86 workloads.
And as we push more proprietary data through these titanium-backed VMs, the security of that data in memory becomes just paramount, which ties directly into the new confidential computing updates, I assume?
It does.
And confidential computing, just for context, is a technology that uses hardware-level isolation to keep your data encrypted while it is actively being processed in memory, not just when it is resting on a hard drive.
Right. And the expansion of confidential space here is really robust. So we're seeing the preview of the confidential G4 machine series, open source prompt encryption SDKs, Apple private cloud compute support, and crucially, support for NVIDIA Hopper GPUs.
Keeping data encrypted while a Hopper GPU is actively processing it, that is a massive engineering feat.
Really?
I mean, it's clear why Google was positioned highest for their ability to execute in the inaugural Gartner Magic Quadrant for AI infrastructure.
Definitely.
But, let's pivot to the human element for a second. We have secured the infrastructure, but human practitioners, the SREs, and the developers listening to this, they still have to monitor these systems. And maintaining your sanity in a rapidly changing landscape like this is just as important as maintaining your servers.
It really is. Which brings us to the operational reality of pager fatigue.
Oh, the dreaded pager fatigue.
Yeah. SREs are just drowning in alerts. So to mitigate this, GCP introduced long look-back alert policies for PromQL in cloud monitoring.
And cloud monitoring is the central hub for collecting metrics and logs to understand your application's performance.
Right. And this new feature, which is currently in preview, allows you to evaluate up to 2 years of historical metric data when setting a single alert.
Okay, when I saw this, I really had to pause. Why on earth would I need to look at 2 years of historical server data just to set an alert for today?
Because context is everything. I mean, think about it. If you set a static threshold, for example, page me if CPU usage hits 85%.
You are going to suffer from false alarms.
Exactly. A static threshold doesn't know that your e-commerce platform naturally spikes every Tuesday morning, or that your internal traffic drops to nearly zero during the 2 weeks of winter holidays.
The static alert just sees the number cross a line and triggers the pager at 3 a.m.
Precisely. But by analyzing up to 2 years of historical data, the monitoring system establishes dynamic thresholding.
Ah, I see.
It learns your seasonal trends and natural baselines. It knows that the Tuesday morning spike is perfectly normal. So it only wakes the SRE up if the spike is a genuine anomaly that deviates from that historical pattern. It fundamentally preserves developer sanity.
That is a massive quality of life improvement.
Oh, huge.
And speaking of quality of life, Google has completely overhauled how practitioners actually manage their own careers and certifications too, which is great because the traditional recertification process is notoriously stressful.
Oh, tell me about it. It usually involves spending hours in a highly proctored, high-pressure exam environment just to prove you still know how to use the tools that you use every single day at work.
Right. But under the new Google Skills model, practitioners can renew certifications like the Cloud Digital Leader, Associate Cloud Engineer, Professional Cloud Architect, and Professional Data Engineer without that multi-hour exam.
Which is such a relief.
Absolutely. If your certification is still active, you can now take up-to-date courses on the newest tech or earn interactive skill badges that validate your real-world application of the tools in a sandbox environment. And completing those automatically extends your certification validity by a full year.
It's so much better. It acknowledges that doing the actual work is the best proof of expertise. It basically transforms a stressful compliance test into an actual ongoing learning journey.
I love that.
And for those who prefer hands-on learning in a physical environment, the community outreach is expanding too.
Oh yeah, Google is taking this hands-on approach on the road with the Accelerate AI with Cloud Run Interactive Roadshow. They are hitting Sunnyvale, Seattle, New York City, Los Angeles, Boston, and Washington, D.C.
These aren't just lectures, right?
No, not at all. They are interactive workshops focused on building real production-grade AI. And if you can't make it to those cities, the Google Cloud Medium publication is actively looking for practitioners to write and share their own architectural solutions.
Which is awesome.
Yeah.
It's really about building a community of practice, which is vital given just how quickly all these tools are evolving.
We have covered an immense amount of ground today. We explored how AlphaEvolve's agentic harness essentially mutates code to find optimal algorithms. We broke down how Discovery Bench uses the concept of surprisal to systematically map the cognitive limits of our data retrieval agents, rather than relying on those flawed pass-fail metrics.
Right. And we looked at the critical need for isolation using Cloud Run Sandboxes as blast-proof rooms for untrusted code, and how K8's A-Bomb provides SREs with that unprivileged runtime visibility into their shadow AI stacks.
And then we wrapped up with the tools designed to keep practitioners sane, from titanium offloads freeing up CPU cycles, to dynamic monitoring alerts curing pager fatigue, to stress-free certification renewals.
It is a comprehensive evolution of the platform, no doubt. But, you know, if we connect all these disparate updates together, the autonomous agents writing their own code, the databases optimizing their own batch sizes, the dynamic alerts analyzing years of historical trends, it kind of forces us to consider a rapidly approaching reality.
Where are you going with this?
Well, we spent today discussing how we use token spend caps and isolated sandboxes to manage these AI systems, right?
Right.
But consider this. How far are we from a point where these autonomous agents begin analyzing their own cloud billing metrics?
Oh, wow.
How far are we from an AI actively rewriting its own infrastructure code in real time to optimize its runtime costs?
Wait, what happens when the AI becomes its own site reliability engineer? Wow, that is a profound thought to leave you with. An AI managing its own cloud budget and provisioning its own infrastructure. Give that some real thought as you architect your next project. Thank you so much for joining us on this deep dive into the Google Cloud Platform. You can subscribe or send us your feedback via the newsletter links in the show notes. Stay curious, build safely, and we will catch you on the next one.